At a time categorizing the different types of numbers that we use in math. So first of all, we have the word rational. Rational numbers are any numbers that can be written as a fraction in fractional form. It could be a whole number as well. Whole numbers are even better, okay? But anything that can be written in fractional form is called a rational number. So that means all the decimals that have recurring decimals, so that'd be like 0.777777, those can all be written as fractions, even though they're decimals. So there's actually a lot of decimals that can be written as fractions. There's only a few out there that we can't. And so the second dot point here says, Pythagoras and his followers discovered in around 500 BC that not all numbers are rational. Pi, because Pythagoras is, there's pi is one number that we're very familiar with. Pi is an example of an irrational number. So have you guys seen the posters around the maths rooms that pi is 3.14159, blah, 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 blah. It's a number that goes on forever, and there is no repeating pattern in it. And if there's no repeating pattern in a decimal, or if the decimal doesn't end, there is no way to turn it into a fraction, okay? So the one way to identify whether something is rational or not is whether when you type it in your calculator, you can see a pattern to that decimal, okay? If there's a pattern, then it's rational. If there's no pattern, then it's irrational, okay? And root 2, so we've got pi, and root 2, anything with a square, a lot of numbers with square root signs are often irrational. So this massive big thing here, that is what the square root of 2 is to 100 decimal places. That doesn't look like 100, surely not. Anyway, I think I might be missing a line. It's to a lot of decimal places. Okay, so you can see 1.41421362377. There's no pattern there. You keep looking at that decimal and there's nowhere where it just starts over and starts again and starts repeating. So that is an irrational, so we're going to highlight, this is the irrational numbers when there is no pattern to the decimal. Okay, so we have this diagram here to help us give an example of different types of numbers. So we're going to have rational, irrational, real, integers, and counting numbers. They are the 5 different types of numbers that we're going to be talking about. So the first big category, that all the things that we're talking about are what we call real numbers. Obviously, we only talk about real numbers. Believe it or not, there is such a thing as unreal numbers, but they only exist in Extension 2 Maths in Year 12. And that involves square rooting negative numbers. So for pretty much everybody else though, every other number that we know about is what we call a real number. Okay, then we can break that into 2 categories. We have our irrational numbers over here, and we're going to have our rational numbers over here. And now, so the irrational, just a reminder, the irrational ones are things like pi, and the square root numbers that we did square root 2 before. I'm going to put square root 5 just to be different. Or it's basically any decimal, 3, 5, 7, 1, I'm just going to put dots there. Any decimal that has no pattern to it, dot, 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 as in that, those decimals will keep going with no real pattern. Those are the irrational ones. The rational numbers are obviously whole numbers, okay? They are fractions. They are decimals that have a pattern to them. So something like 0.4 with a repeated dot on it. Okay? They are also decimals that have an end. So like 0.82. If it just ended at the 82, we can write that as a fraction. Okay? So those are my rational numbers. Now inside the rational numbers, we have 2 little categories that are more specific than that. We have things called integers. Now you would have learnt about these in Year 7. Does anyone remember what an integer is? We did a whole topic at the very beginning of Year 7. It was a bit of a while ago now, wasn't it? Okay. So integers are your whole numbers, positive and negative and 0. Okay. So you can have things like -2, -20 if you wanted to. You can have 0, but you can also have positive numbers. 7, 51, negative numbers, positive numbers, and 0 in the middle. And if I get even more specific than that, we get the counting numbers down here. We don't tend to count in negative numbers, do we? You don't count things in the negative normally. Okay, so they are just your positive counting numbers, starting at 1 and anything positive, any positive counting number. 1, 9, 15, any positive counting number. Okay, normal counter, like when you're in kindergarten, when you start counting, they're the ones you learn. Okay? All right, so they are all our categories. We have a little box down the bottom here to help us remember a few things. Equivalent fractions. You heard that word before? Equivalent fractions. Yeah, good. Are fractions that have the same value. So it says, for example, there. Here is the easiest fraction that I can think of. 1/2. Okay, easy fraction. Can you think of a fraction that is equivalent to that, which means the same as that? 5/10. Perfect. You doubted yourself. Well done. 5/10. Anyone else brave enough to try now? Yeah.
25/50.
Yes, well done. They are all equivalent fractions. You guys are just making, you're like just going, whatever I want the bottom to be, the top's got to be half of it, right? Or the other way around, choose the top and double it for the bottom. Okay, that's a half. All right? So those are all equivalent fractions. Fractions can be simplified by dividing the numerator and denominator by the highest common factor. Remember that lovely word? That's another Year 7 thing. Highest common factors. Now, we have calculators, something you probably didn't use in Year 7. So we're going to be doing most of our simplifying on our calculators. But basically what it's saying is if I had this, let's take this one here, 5/10. If I wanted to simplify that fraction, I'm looking at them and go, I can divide both those numbers by 5. If I divide that by 5, I get the 1. If I divide that by 5, I get the 2. And it's how you reduce it back down to the most simplified fraction. Yeah, simplifying. Okay, third dot point. A proper fraction. Can anyone, I should read it for you first. A proper fraction has its numerator smaller than its denominator. Who could tell me an example of a proper fraction? Making one up. Anton, I know you want to.
Sorry?
Give me an example of a proper fraction where the numerator is smaller than the denominator. Numerator means top number, denominator is bottom number. Too scared? Val, you want 10? No? Too scared? Come on.
1/2.
Yeah, 1/2. I don't want to use that one again because I already used that one. How about a different one? Pick a small number and then pick a bigger number.
25/50.
Yeah, okay, all right, cool. All right, so 25/50. Anything where the top number is smaller than the bottom number is a proper fraction. Okay, so it could be 2/3, could be 5/7, could be 11/59. Don't care. As long as the top number is smaller than the bottom number is what we call a proper fraction. Okay, so maybe you'd then know what is an improper fraction going to be. We're going to flip that now. It's when the top number, the numerator, is bigger than the bottom number. Will, give me an example.
8/2.
8/2. 2. Oh, sorry, I thought you said 10 for a second. 8/2. Perfect. Okay, bigger number on the top, smaller number on the bottom. That's called an improper fraction. And then we have the ones that are mixed numerals. Now, anytime that you have an improper fraction, these ones here, anytime you have an improper fraction, you can turn them into mixed numerals, okay? And they are the ones where you have a number out the front of your fraction. So, for example, I'll tell you one of those. Something like 2 3/4. So I have 2 wholes, and then I have 3/4 of a fraction as well. That's called a mixed numeral. Fractions can be compared only when they have the same denominator. And the last dot point, a dot or a bar is used to show a recurring decimal number. So I already showed you one of those in the little diagram that we had. So, for example, we had I don't remember what number I used before. I'm going to use 0.7. I put a dot above it. That means that's the same as 0.7777777. The dot is telling me that number is repeating. Now, normally if there's only one number repeating, I tend to use a dot. Okay, nice and quick, put a dot there. But if I have 0.517 and then it was going to go 517, 517, 517, when there's more than one number repeating, you can either put a dot on the first number and a dot on the last number, or what's, I think, less confusing is the bar method. So you put, oh, that's a bit messy bar. Let me try that again. You put a bar that goes all over the top of the numbers that are repeating. Okay, so that's the dot and the bar method. Okay, over here, examples. This is what you're going to have to do. Circle the rational numbers. All right, quick brain check time. What does rational mean again? Sorry, what? Don't have many of them. Maybe you're on the right track. Not quite clear enough though. What does that mean? Not quite many of them. What does rational mean? Look back at your sheet. Yes, Will? That you can write it as a fraction or it's a whole number. It's the ones that don't have the big yucky decimals, right? So, square root of 9, grab your calculators out. Square root of 9. If I type square root of 9 into my calculator, what does it equal? No, square root, not square. The square root button, the big... Do you get what I got? Square root of 9 is 3. That is a very nice number. There's no decimal there at all. So that one is going to be rational. Okay, let's circle it. It's rational. It came out as a whole number. Okay, let's try the next one. Type in now square root button. Everyone knows the square root button. That's right here. Square root of 3 equals. Okay, we've got a decimal this time. 1.73205. Is there any pattern in there? No. So that one's going to be irrational. Not going to circle him. We don't want that. We want the rational ones. 0.6. Okay, there's nothing to type in the calculator there. 0.6. It's a decimal, but it's a decimal that has an end. Is that a rational number? Yes. Any number that has an end, a decimal number that has an end, is a rational number. How about pi? If you want to see pi, here it is. You go shift, press that button, equals. There's the start of pi. In fact, I don't only show you the first that many decimal places. No pattern, as we know, is pi a rational number? No pattern there, so not that one. Okay, 4/5, it's a fraction. A fraction's rational? Yes. Fractions are rational. It's only things that cannot be written as fractions or whole numbers that are irrational. What about square root of 7? Square root 7 equals. Rational or irrational? Irrational, good. So don't circle it. Next one, 5. It's a whole number, so is it rational or irrational? Rational, good. Circle it. 8.887. Okay, it's only the decimals that we have to really think about. Everything else is rational, right? This one is a decimal, but it's a decimal with an end. So is it rational or irrational? Rational. Any decimal with an end is rational. And the last one, 1.54, also has an end, so it's rational again. So lots of rational ones in there. Okay, question 2. We now want to get into the questions where we're going to be changing between fractions and decimals. Okay, now to do this, you're going to be using your calculator. All right, calculators be very handy as long as you can remember the right buttons to use. So, everybody do this, please. You need to type in 3 and 3/8. Now, that's what we call a mixed numeral. Don't just use the normal fraction button and then backwards to put the 3 in front. You need to press Shift fraction button to bring up the 3 boxes. Okay? So you need the 3 boxes, and then you're going to put the 3 out the front, and you're going to have 3 on the top, and then you're going to have 8 on the bottom. Can everyone do that? Good. Press equals. Now your calculator likes to keep things as a fraction, but you wanted to change it into a decimal. Does anyone know how to do that? You do? Yeah, you press the SD button. So this one right here. If your calculator gives you a fraction and you want a decimal, you push that button. Whoop. Don't put my hand on the screen. Okay, push that button and it changed it into a decimal for me. Okay, I don't have to worry about whether that's rational or irrational. I just need to write down what that decimal is. 3.375. So that is equal to 3.375. I've turned my fraction into a decimal. Okay, question 3, I have a fraction again, and I want to turn it into a recurring decimal. We do it the same way on the calculator, so type it in. It's only a normal fraction this time though, isn't it? It doesn't have the big number at the front. So normal fraction button, 5 on the top, 13 on the bottom. Press the equal sign first. Don't try and press that SD button if you haven't pressed the equals to sign. It won't work, okay? So pressing the SD, it turns it into a decimal. Okay, we've got 384615. 3846. Oh, your calculator can only fit so many numbers, but you can see it's starting to repeat there, isn't it? Okay, so even though that looks like a very long decimal number, the 3, the 8, the 4, the 6, the 1, the 5, those 6 numbers are what is repeating, and then it starts again. 3846. Alright? So it is a recurring decimal. Okay, we have the dot method, we have the bar method. I'm going to remember that. 384615. 0.384615. Did I get that right? Because as soon as I touch my screen, my calculator disappears. Yeah? Alright. Am I going to use dots or a bar to show that that's repeating? Bar, because it's a lot of numbers there. So we put one big bar across the top of all of it, and that says that those decimal numbers are repeating. Okay, we want to go in reverse now for number 4. Write these decimals as fractions. I think that's even easier, because our calculator likes fractions. If we type in 0.24 and press equals, oh no, it didn't do it for me. I just have to press that SD button again, put it back the other way. You can keep pressing that SD button as long as you like, as many times as you like, and it'll do fraction, decimal, fraction, decimal, fraction, decimal. Okay? Just keep pressing it, it keeps changing it. Alright, so 0.24 is the same as 6 over, or what was that denominator again? 25. Alright, try the next one. Type it in, everyone do it. Do you have a calculator, Clayton?
Yeah.
You do?
Yeah.
Alright, cool. Type that in, 2.385. What do we get? Press equals, and then what do I press? SD. Not a nice fraction, but it's still a fraction. 477 over 200. Okay, decide which is larger. 4 over 5 or 5 over 7. Now, fractions are tricky to compare if the denominators are different. Okay, because you think, remember way back probably in primary school when you used to draw little pies of these things, one of them's cut into 5 pieces, one of them's cut into 7 pieces, which one's actually a bigger piece? They're hard to compare if they're different denominators. So you can get common denominators and do all sorts of lovely fractions tricks, but it's actually easier if you turn them into decimals. Decimals are easy to compare. Okay, decimals is easy to see. So let's use our calculator again. Let's type in the fraction. 4 on the top, 5 on the bottom, press the equals button, and turn it into a decimal. So that first one is 0.8. Okay, just putting that underneath there for a second. Let's try the second one. The second one is 5, whoops, I pressed fraction and fraction there. 5 on the top, 7 on the bottom. Whoop. Go down. Okay, press the SD to turn it into a decimal. That one has a lot more decimal places. I'm just going to write 2 of them down. I'm going to go 0.71. Because that's all I need. I can easily see which one's bigger and which one's smaller now, can't I? Which one is the larger fraction? Larger fraction. I want the larger place. This one's larger. Okay, so I want the larger number. Now the decimal was just how I worked it out. When I circle it, I'm actually circling the fraction. This is the larger fraction. Okay, it had the bigger decimal, so that's the bigger fraction. Okay, do 5b. Both of you, all of you. 5b, type in the fraction. What is 2 over 3 as a decimal?
2.3.
Nope, unfortunately not. Type it in.
0.6.
Yeah, so you can go to 0.6. That's a repeating one, so you go 0.6 with a repeated dot on it. That's because your calculator can only fit 10 digits or whatever across the screen. It will always round the last number, and 6 is round up to a 7. So yeah, don't be worried about that bit. Try the next one. 3 over 4. What is that as a decimal? Anton? What is it? 3 over 4. Come on. Got to practice it now so you can do it when it's your turn. Excellent. So, Ashton, which one is bigger? 0.4 decimal. So which fraction am I going to circle? 3 over 4. Okay? Where the decimals are just helping us see which one's bigger, but we've got to circle the fraction. All right, that's it. That's what we're doing today. Your turn. Exercise 1D.